Welcome to You've Got Potential, a podcast about the stories and work of undergraduate research. I and the other original hosts graduated in May, so we've got some other undergrads hosting the podcast now, including.
Hi guys, my name is Akanksha and my pronouns are she, her.
My name is Liesel. My pronouns are she, her.
Hi, I'm Natasha and my pronouns are she, her.
Hi guys, I'm Shrey and my pronouns are he, him.
Hi, I'm Zach. My pronouns are he, him.
So we've introduced all of them in more depth in our previous episode. Ironically, though, we haven't talked much about our own stories with research or where we're going after this podcast. So today, our new hosts will be chatting with me about that. Take it away.
Awesome. Well, thank you so much, Eric, for coming back to talk to us. So if you want to start off by just talking about your research project and what you've been working on lately.
Okay, so I could go into a little more depth about the backstory to my current project or the trajectory, but I'll give you the current spiel. So I'm doing molecular dynamics simulations of a protein, and molecular dynamics, basically, you're simulating the movement of molecules, as the name suggests. And it can be pretty complicated. You have a lot of different methods, and we could go into more depth about that later if you guys want. But the protein I'm focusing on is kindlin-2, which is of interest to my lab, spearheaded by Andy Newcoop. It's of interest because it's overexpressed in the cells, well, the tumor cells of a lot of different cancers, including breasts, lung cancers, brain cancers, etc. And I'm trying to understand how different conditions may affect it, because there's this idea in the literature from other people in my lab suggesting that whether you add or remove a proton from the target, well, one of the targets of the kindlin-2 protein, that being this phospholipid on membranes called PIP3, if you change whether there are protons on certain parts of PIP3, then it may affect how it binds to there. And if we understood that activity, then that might allow us to better design drugs to control kindlin-2's activity, since it's involved in cells growing and dividing, and those processes obviously get out of control when it comes to cancer.
Okay, really cool. So how and why did you settle on your current project?
So it originally began through the Rutgers Research Assistant Program, which pairs undergrads with researchers at Rutgers. And I picked the new Coop lab out of all the other labs that I was interested in at the time because it afforded a lot of independence from what I can tell. The project description mentioned getting to optimize your own platform for expressing certain proteins that the lab wants to study. And that really interested me because after talking with a TA I had in a lab course, they mentioned that it's important for a first research experience to have a lot of independence and not just basically be pipetting stuff. So I went for that lab, even if it was a little different from my core career interests, and mostly worked on the sort of project that was advertised, though mainly on figuring out how to best design the plasmids that we're using to express the proteins and make them in bacteria.
Wow, that's really cool. That sounds like really cool work. And you mentioned like that aspect of independence was like something that was really important to you. So how was that experience in the lab environment itself? Like, what kinds of things did you learn in that lab?
So this was during the pandemic, so I ended up working from home, and that was definitely a big factor contributing to my independence because I couldn't easily interact with people in the lab. And aside from that, though, that combined with the fact that the lab was generally very hands-off, they paired me with a graduate student who was more experienced in this line of work. Like, they dictated some of the direction that I would take in terms of what tasks I would complete, but they would be fairly open-ended with everything. Like when it came to designing plasmids. I was mostly contacting the company that was going to be shipping them myself until the last minute when I had to hand it over to my PI to sort out the funding business end of things. And I'd say even after that project, there is a lot of independence in my lab. We will have, usual like weekly or bi-weekly presentations. We'll also have more one-on-one progress reports, but in general, you can very much approach the problems you're faced with however you want, since our lab is also pretty diverse and experienced in lots of different areas. So not everyone will have good advice on, whatever you're working on. Like I'm one of 2 people in my lab that works on simulations, for instance.
Yeah, that's really cool. I like how you mentioned that you got to do like pretty much your own work, kind of like you mentioned you got to do your own simulations and stuff. So that was like really interesting to hear about. And can you tell us more about like what these simulations like consist of? What's it simulating exactly?
Okay, so while Kindle-2 is normally a membrane-bound protein, one problem with MD simulations a lot of the time is they can take really long to run, especially if what you're simulating is large. So I had to remove the membrane in this case, especially since this isn't for my Arresti project, by the way. This is for something afterwards. I chose to stick with the lab because I liked the work there. I was also kind of pressed for time, so I didn't want to do a bunch of cold emailing to professors, and I felt like there were good enough opportunities in the lab to build the sorts of skills I want. But as for the simulations themselves, they contain the protein, more specifically the plextrin homology domain of Kindle-2, which is the part that binds to PIP3, and PIP3's head group, this little molecule called IP4. So there's also in some of them water molecules. Since it's inside the cell, there's lots of water. If there isn't much water, your body's probably doing something wrong. But that is either modeled explicitly, so you'll have little water molecules bouncing around, or implicitly. So you have like these general force fields. You can think about it like a magnetic field or some other field running through the space in the simulation to roughly approximate what water will do to it.
So from my understanding, like you're putting the protein through like a bunch of different situations, just to see what happens to like the shape or functionality of it. Is that what it's about?
Yes, and even though I mentioned that these simulations can take a long time, for simpler systems, it can usually be pretty reasonable, on the order of like a few days. You can get a couple nanoseconds of time that's simulated. But one of the good things that MD simulations are really great at is being able to test basically anything you want. So there might be some conditions that might seem insignificant and not worth a full in-lab experiment, but you can use them to easily set up any kind of system that you want and modify it however you'd like. And at very little cost, you can see what happens and make some predictions. So in my case, some of the variables I was considering was, firstly, how does pH affect the protein? Because when I was mentioning before, the other person in my lab who does simulation work, he suspected that pH can control the activity of Kindle-2. And I wanted to test that by seeing if we vary the pH from values of like 5 to 8, which normally pH is pretty close to 7 in the cell. So even at these extremes, I wanted to see how it might fare, because I'm only doing so many simulations. So, the difference might be insignificant in a small sample if the pH difference is smaller. And then from there, I wanted to look at how protons were added or removed to the protein, how its folding might have changed, because of course proteins can denature and lose their folding at different pH values than they're used to. And then from there, I wanted to look at what were some of the most common states, like in terms of where protons were, and try to test those when binding to IP4. And also test the different protonation states on IP4 itself in order to see if they bind substantially differently, like our prior research has found, or if these differences don't really matter or they don't even exist.
Was there anything that you wish you knew before starting this project in comparison to now?
Yes, so it's definitely been an adventure learning how to use the software that I'm doing my simulations on, which is known as Amber. Like for a while, I was using an older version that was made in 2016, and I didn't realize that they had a 2020 version that was installed. I remember having some issues with getting it running, but now for my research after I graduated, which I'm doing in the hopes of possibly filling in the gaps of my thesis project and getting a paper out of that, I am realizing that I'm able to use the 2020 version of Amber. I'm also learning a lot about the computing cluster that I've been working with, because these simulations can take a lot of computing power to run at reasonable time lengths. And I definitely can't do it on my really old PC. So I've gotten a lot of help from those people at Amarillo. And especially in terms of how I've set up my simulations. Like there are lots of techniques I didn't even realize could increase the speed of what I'm running, and maybe set up jobs, since there's like a 72-hour job limit and usually my simulations go above it, to queue them so that when one job finishes, another starts. So there are a lot of technical things like that, which I've also learned a lot about outside the software itself. And I would definitely say for anyone looking to do MD simulations or really any sort of computational biology, read the manual, talk to your IT people. They have a lot of ideas for best practices, and they will save you a lot of time if you start now and learn what you can to do the best job possible.
Yeah, that's really good advice, definitely. So like learning how to use those simulations, like what was that like? Did someone help you? Did you get like official training to use those simulations? Can you tell us about that?
Yeah, so it started off with the other person in my lab who works with them. His name is Robert. And we were initially doing those simulations to test the effects of pH. There was a pretty straightforward guide on doing those. I can put a link in the description of this video or episode if you guys want, for how to run those. And we mostly followed the example of that, though I made some tweaks afterwards when I realized that it wasn't titrating all of the residues, because you have to choose specific residues to protonate or deprotonate, and I didn't choose all the ones I wanted. But we followed that tutorial. I periodically looked through the manual to see if there was anything I was missing, if the parameters that the tutorial recommended were right for me. And Robert was able to answer a lot of my questions. He's very experienced in this stuff, and he's been extremely helpful. And for then moving on to the simulations where I wanted to test the protonation states of IP4 and how they bind to kindolin 2, I didn't have as much of a clear-cut tutorial, but I was able to reuse a lot of the setup from my previous simulations for that, though with some modifications here and there. And that involved things like figuring out which water model to use, because you would be surprised. There are a lot of ways that chemists like to model water. even outside of the implicit and explicit, there are lots of different explicit ones. Like there's a tip 3p water model. There's one with like another pseudo atom in between the oxygen and the hydrogens. They all have their own pros and cons, and they're all compatible with different setups. So I had to read some papers to find the best one and check the manual again to see how compatible they were with everything else. Yeah, and then for analyzing my simulations, there is a lot of software like GNU plot that is used to do that typically, but for my thesis project, I was really in crunch mode at the time, and I was like, I don't want to have to learn all this. I know how to read the data files. I can just edit them using this text editor called Vim that I've been using throughout my project. Yeah, I could edit them with Vim and very easily filter out all the data I need and just plot it in Excel, which is most of what I did. I'm glad that I did some of that because it definitely saved me the learning curve of GNU plot, but it was also a pain in the ass at times because some of the data sets were like gigabytes long and the Excel sheets took forever to load.
So I'm curious, like, did you get interested in this topic like from something in class that you learned, or like how did you get into this field of like proteins folding specifically?
Okay, so I guess I should highlight my broader career goals with this. So going into the Aresti program, I really wanted to do research focused on some area of synthetic biology, whether that was genetic engineering, like making GMO crops, or protein design that could be related to that, just to see like how the re-engineered proteins that we come up with for gene therapies and GMOs and so on work. And also there are lots of drugs that use proteins. So those are generally called biologics, though there are other kinds. And understanding how those work and being able to approach them sort of from an engineering perspective, I really wanted to get into that. So I figured that even though I'm in more of a structural biology lab than a synthetic biology one, there could still be some good transferable skills between the two. And one of the things that my PI and I came up with after I finished my Aresti project was, working with MD simulations, because of course, with engineering, it's often helpful to simulate things, to draw blueprints, and MD simulations are kind of the troubleshooting tool of choice, or one of the troubleshooting tools of choice in synthetic biology.
Yeah, that's really interesting. I'm just curious. I know a lot of undergrads, myself included, are usually pretty back and forth about what our career goals are. And I'm just wondering if having this experience maybe changed the trajectory of your career goals at all, or if you still kind of are sticking with what you originally wanted to do.
Oh, yes. I admittedly have wanted to work in some area of synthetic biology ever since high school. I read a lot about CRISPR and other emerging technologies and the potential they had, and was very excited by that. Though I definitely think, even though I still feel that way, working on this project has changed my perspective, because now I know that I want to work with these simulations, which previously I had never even known about. And it was that experience combined with doing a little startup project with the NSF I-Core program at Rutgers, which works with a computer-aided drug design company that's making some software similar to the one that I'm using at the moment. That really showed me just how vast the possibilities are for this kind of technology, and how convenient it is to work from home, how much I like experimenting with the different designs for the systems I'm testing in these simulations. I like the flexibility. I like that I can do this at a very low cost and from basically anywhere. So yeah, I'd like to work more with that in the future.
Nice. It seems like you really enjoy what you're doing right now and you've really found your place. I'm curious to know, what do you think your next steps moving forward are? Do you have any plans for pursuing a PhD?
Yes, you're right on the money with that one. So I am pursuing a PhD at Penn State, which is a decision I still very vividly remember, and I could tell you guys a lot more about that one if you'd like. And this PhD is focused on biochemistry, microbiology, and molecular biology. That's the name of the program. So uh, in that one, I don't know exactly what sort of research I will be doing next. I would like to continue doing simulation work, and there are some options for that at Penn State. But there are also some other options that I'm exploring. I'm actually talking with professors very recently. Like I spoke to some yesterday, and I'm speaking to some more later to figure out which projects I'd like to do rotations with.
Were there any other potential career or any other future directions you had that you had to kind of debate between? Were there any things that were there important factors that you really had to consider before choosing to pursue that PhD degree?
Yes, so me finally deciding to go for a PhD was a process in and of itself. It started, I think, with this one class. I forget the name of it, but uh, it was with Dr. Samuel Gunderson, and it talked a lot about career options. And you got to speak with people in industry and academia to get a sense of what it's like working with biochemistry. And it was that experience and talking with those professionals that really compelled me to do a PhD. Because even though I already have a sort of thesis project under my belt from my undergrad years, it's not quite the same as doing that sort of project for 3 to 5 years with maybe 2 years before of classes, like a typical PhD. And I wanted to have the independence to do my own thing and not just get thrust into the demands of whatever particular company might be out there looking to hire me. I'll be saving that for later, but I wanted to really thoroughly see if I liked using MD simulations for the sort of computer aided protein or drug design that I thought I would, and what other options might be out there, since of course my experience at Rutgers was what originally convinced me to work with these simulations. So I wanted to see if there might be more that I'm missing out there. And I feel like a PhD not only would be a good demonstration of my ability to do independent research and important for the sorts of executive high concept projects that I'd like to work on afterwards, but I also think it'd be a good chance to explore with some guidance from the program other ideas for the sort of research I might like to try in the future. Even though I know a PhD doesn't have to be exactly the sort of research you'd like to do, I'd like to begin with the end in mind.
So, Eric, you mentioned before in high school previously that you were interested in synthetic biology because of the CRISPR research that came out, and your project kind of simulates a similar topic involving the research of cancer. So my question to you is like, is there any books or papers or resources that really stood out to you in your educational career that led you to this project?
So there were a lot of different things. Most of it was just reading the news, watching videos on YouTube, especially those exploring upcoming biotechnology, like Seeker, the YouTube channel used to always be one of my big favorites. And in terms of books, I think, what was the one I was thinking of? I might have it on my shelf back there. Well, Regenesis by George Church and Ed Regis. That book explored a lot of different kinds of biotech and their futures, and that's been a big factor in getting me excited about the field initially. I've also learned a lot at Rutgers through being part of the bioethics society there and having some interesting conversations about the ethics of existing and upcoming biotech. Yeah, I'd say those are probably some of my main like outside influences.
Yeah, all of the work that you're doing sounds really interesting. And I was wondering, maybe for people who already have interests in the same field that you're in, or maybe people who are listening to this and are getting interested, do you have any advice for newcomers who are maybe interested in this field on classes they can take or clubs they can join or just experiences to see if this is right for them?
Okay, so yeah, I have not looked through the set of classes available at Rutgers lately. Would definitely recommend doing that because there might be some gems in there that could help you specifically with this. I was definitely able to learn a lot on my own and with help from Robert, but not everybody has a Robert in their lab. So in those cases, it's good to prepare. It's good to get a more consistent training program directly from an expert because there are lots of different guides that you can check. Like the Amber website has tons of different ones for different simulation setups, but it's good to just get a solid foundation in how everything works and then check out the more specific guides for your needs. But just knowing what options are out there can really help you.
I was thinking about like all the things you said earlier about like writing your thesis and like all those resources that you had to read to like make sure you were like up to date with everything and just like doing your best with the simulation. And I was wondering like what that process was like just doing a research thesis because I know that a lot of science majors who might be listening to this they might be thinking about doing a senior thesis. So could you tell us more about that?
Yeah, so there's a specific class in my major, molecular bio and biochem, dedicated to this. You start off in the fall traditionally, and they ask you some questions about what your project will be. You submit a proposal, usually even during the summer, like I did. And then they help guide you through the process of knowing how to write a thesis, how to do background research. They get you compiling some sources on a topic that you're researching just to make sure you have something going into your thesis. They also will gradually have some presentations, like there's one where you give your research proposal to the class just to help get you acquainted with speaking about your topic. And then from there, you have several drafts of different sections. Like you'll submit one draft for the intro, one for materials and methods, and then several previous drafts prior to your final one. And I would also recommend definitely get your final draft in early as possible. Like traditionally, you have about a week or 10 days in order to give your PI and whoever's on your committee time to review your thesis, because the defense, it's all about asking questions, presenting the full scope of your research, and getting their feedback and their grading on it. So prior to that point, you also have to select people in the MBB department to be on your committee. You get the gist of the course up to this point. There are more details I could cover, but in general, they help you gradually work towards that thesis. And ideally, you won't be writing the intro like 2 weeks before it's done, which thankfully I was able to avoid doing because I already had a draft of it.
That's great. I like how Rutgers has like such resources like that where you really have that support system and programs in place just to like help you through every step of the process. And I've been like uh looking into what I want to do after graduation and it sounds like that kind of experience is almost like a mini um simulation of like what it's like to do a PhD because I've heard like similar things like oh you're gonna have to do your research, draft your papers to get it submitted and like defend it. So I wanted to ask more about like now that you're at the end of that like chapter, I guess, and you're looking forward into your PhD. What advice do you have people who are thinking about doing a PhD? Um, what advice do you have like for applying or just things you wish you knew while you were going through that process?
Oh, yes. Okay. There is a lot that I could cover. I think at one point we even tried making a whole episode about grad school advice, but we just never found time for that. But to give you the Cliff's Notes version of some of the key points, firstly, figure out if you want to do a PhD. Go look at some resources people have on what it's like to do one. They could probably tell you a lot more than I have. Watch some videos, read some articles, whatever works for you. I know Simon Clark's YouTube channel is a good resource for that because he has some good tips on whether you should do a PhD and what it's like. He documented his whole process doing one at, I think it was Cambridge. And okay, after you've decided whether you want to do a PhD, whether you think the commitment is something that's worth it for your goals, which is another important thing to keep in mind as well. Look into your career path, ask some people you might be interested in who work in a similar field, like what can you do without a PhD? Is that something that would interest you? Should I take a gap year before deciding and maybe take a job up in my spare time? And after you've made that decision and you know your heart's set on a PhD, be very careful about figuring out where you want to go because you're not just applying for a set of classes. Classes are definitely less important than they were in undergrad. They're more to give you ideas for your research. Don't just go for a project. Go for a place where you would genuinely want to live for the next 5 to 7 years. Because I think it's easy, especially for someone like me who commuted to Rutgers, to not really think of your university as a home in that sense. Sure, I was involved in lots of clubs and stuff there, but it's very different from living there. So uh, once you've looked through good PhD programs in your specific field, because college ratings and whatnot aren't very specific, uh, talk to some students that you might know who are in labs that might interest you. Look around on campus, see what kinds of amenities there are. If you think that moving away is going to be a difficult adjustment for your mental health, your physical health, etc., look into the housing resources, see how much it costs, see if there are gyms or whatnot nearby, if the school has free counseling services or whatever you might need. Yeah, I could basically write a whole book about my process for figuring out how to apply. You might be seeing that someday. I don't know.
Those are some great tips for people considering doing a PhD. And another question I have for you is, what major takeaways do you have for doing the research that you've done at Rutgers so far in your undergraduate career?
Yeah, I think we've addressed a lot of different nuggets of wisdom so far. But aside from that, the importance of having some independence early on in the lab, since that can be a really good test for whether you like research and what kind you might like, what mentoring style appeals to you, and what sort of role you may want in a lab. Do you want to be at the head deciding what sorts of projects do you do, or do you want to be more of a technician? You know, having that taste of very strong independence can't, but with some, guardrails to help guide you, can be a good way to get a feel for that. To borrow a phrase I learned during working as a co-entrepreneurial lead in that I-Corps program over the summer, you want to fail fast in a sense. You want to see what will be a deal breaker for you as soon as possible in what you pursue. So if you're not sure about whether or not you would like to do research remotely or you would like to do it all day in a lab, go for that. Don't just be like, I see these different projects in my RSD program or whatever, and I'm not sure if I would like it because of that. I don't want to take that risk. No, do take that risk. Decide. It'll help you decide if that's the kind of work or the style of work that you like in the future. And in terms of research more generally, I would say it often helps to begin with the end in mind. You know, for me, I recall that one of the big driving factors in what sorts of projects I did was getting towards that experience with synthetic biology techniques. So if I didn't know that I wanted to work in synthetic biology in the future, I probably wouldn't have been doing MD simulations. I might have been doing NMR or the other things that my lab specializes in. And definitely do your homework early on, whether it comes to reading the manual for simulation programs or figuring out what sort of grad school program you might want to apply to. It really helps you in the long run. I know it might seem easy to just look up best graduate schools or best PhDs, but really ask yourself if you want and need a PhD for your goals, and that's much easier to do if you begin with the end in mind.
Yeah, thank you.
Eric, thank you so much. We learned a lot today. Thank you so much for talking with us, and thank you for the work that you've done to help start this podcast. And we are all honored to keep it going. Best of luck for the future. I know you are going to kill your journey. It's looking so exciting for you. With all that said, remember that you've got potential. Bye.